and this is still part of the trigonometry standards number 2 and trigonometry standard number 4. So today we want to be able to graph the sine and cosine functions and ones that have various amplitudes and various periods. That's our goal for today. To start, we need to remember some of our sine values. And to do that, we're not going to use our calculator, so we're going to remember our 45-45-90 triangle, our 30-60-90 triangle. Remember, square root of 2 is approximately 1.414, and the square root of 3 is approximately 1.732. Now let's fill in this little chart. Here we have all our angles measured in degrees, 0, 30, 45, 60, 90, 120, 135, all the way through 360. Let's just for fun fill in all the radian equivalents, and you can look at those later, whether it's the sine of 30 degrees or the sine of pi over 6 or the sine of 0. Let's try to fill that in. Sine of 0 we're going to have to remember from the unit circle, and as we go to graph this, the sine of 0 is 0. So on our little graph, we're going to go up to 1 for the y value, down to -1 for the negative y value. And we're going to go out from 0 to 360, and at 0 degrees for the x value, sine is 0. Sine of 30 is a half, so at 30 degrees we're going to have a half. Sine of 45 is the square root of 2 over 2. Square root of 2 is approximately 1.4 divided by 2 is approximately 0.7 at 45 degrees. The sine of 60 is the square root of 3 over 2, so 1.7 approximately divided by 2 is approximately 0.8, and we'll plot that. Sine of 90 degrees is 1, so we'll fill that in. Sine of 120 has a reference angle of 30, it's in quadrant 2, and it's positive, so it's the square root of 3 over 2 again, which is 1.7 divided by 2, or 0.8 approximately. 135 has a reference angle of 45, so square root of 2 over 2 is 1.7 divided by 2, or approximately 0.7. 150 has a reference angle of 30. Sine is again positive in quadrant 2, so that's 1/2. And the sine of 180 is 0. So sine in quadrants 1 through 90 and 2 through 180 are positive. Looks like we're going to end up with some negatives. 210 has a reference angle of 30, and that's 1/2, but it's in quadrant 3, so it's a -1/2. Sine of 225 is negative the square root of 2 over 2, so that's -1.4 divided by 2, or -0.7. Here for 240, that has a reference angle of 60, so that's negative square root of 3 over 2, or -1.7 over 2, or approximately -0.8. Sine of 270 using the unit circle is -1. So sine in quadrant 3 is negative, and looks like it is in quadrant 4 as well. 300 has a reference angle of 60, so that's negative square root of 3 over 2, or -1.7 divided by 2, or -0.8. So again, the sine of 315, that has a reference angle of 45 degrees. It's negative the square root of 2 over 2, or -1.4 divided by 2, which is approximately -0.7. 330 is a reference angle of 30, so that's 1/2, but in quadrant 4 it's -1/2, so 330 sine is -1/2. And using the unit circle at 360, sine is 0. So if we connect the dots, that's the basic sine curve. It looks like an S shape. And we'll find out momentarily that that S shape will repeat over and over and over again, and that's called the period of the sine graph. But we want to be able to graph it without using calculators. In pre-calculus, you'll do this, only instead of using the degree measure as I was using today, you'll be referring to radian measure as we do everything in radians from there on out. So here we go. We can see again in quadrant 1, between 0 and 90, sine is positive. Quadrant 2, between 90 and 180, sine is positive. Quadrant 3, between 180 and 270, sine is negative. Quadrant 4, between 270 and 360, sine is negative again. All right, what about graphing the cosine? Well, you're going to do the exact same thing we just did with this chart with the cosine as part of a homework assignment. so we're going to leave that for now. And we'll tell you that sine and cosine are called periodic functions because their basic shape repeats every 360 degrees or every 2 pi radians. So we therefore say the period of sine and cosine is 360 degrees or 2 pi radians. You can think of the sine curve as a basic S shape on its side and the cosine as a basic U shape. And if we look at some generalities, sometimes we have some coefficients like a here in front of sine and in front of cosine that we are multiplying the sine function times some number a or the cosine times some number a. And then we have another number called b, which we're multiplying by our angle theta. A represents the amplitude of our graph, which is the distance from the x-axis to the highest point on the graph, and likewise the distance from the x-axis to the lowest point on the graph. B is going to affect not the height of the graph, but how long it takes to repeat its periodic shape, so it's going to affect the period. How that affects the period? Well, we'll take the 360 and we're going to divide it by the absolute value of that number b, and that will give us the new period of that shape. So as we generalize graphing, let's look at some characteristics of the sine curve. At 0 degrees, or the beginning of its period, it's 0. A fourth of the way through its period, it hits the maximum. Halfway through its period, it's 0 again. 3/4 of the way through its period, it's a minimum value. And at the end of its period, it's 0 again. If that number a is negative, then we just rotate this across the x-axis, so the maximum becomes the minimum, and the minimum becomes the maximum, and the zeros still stay the same. So to graph this, let's just make a little sketch of the graph. And the heights and the lowest part, the maximum and minimum here, are going to be +3 and -3. Now to find the period, we're going to take 360 divided by the absolute value of 2, which is 180. So I'm just going to draw this out to 180. It's going to repeat its shape there. Halfway across 180 is 90. Halfway across 90 is 45. 3/4 of the way across is 135. So sine starts at 0. Fourth of the way through its period, it hits the maximum. Halfway through, it's back to 0. 3/4 of the way through its minimum, and it's back to 0 again. So we sketched that in, and that's as easy it is to sketch in some sine curves. We again say the amplitude is 3. The period is 360 divided by the absolute value of 2, which is 180, or 2 pi divided by the absolute value of 2, which is pi radians. So let's do a negative one. This negative means we're going to go up to +1/2 and -1/2. But where the maximum was is now going to become a minimum. Where the minimum was is now going to become a maximum. For the period, we're going to take 360 divided by the absolute value of 1/2. And instead of dividing by a fraction, we'll multiply it by its reciprocal. So 360 instead of divided by 1/2 is 360 times 2, or its period is going to go out to 720. Half of that is 360. Half of that is 180. 180 and 360 is 540. So we've divided that period into fourths. Going to go up to 1/2, down to -1/2. Sine starts out at 0. Normally, a fourth of the way it hits its maximum, but since a is negative, at a fourth it's going to hit its minimum point. Halfway it's still 0. 3/4 of the way would normally be its minimum, but since this is negative, we're flipping it over, reflecting it across the x-axis, and it'll hit its maximum. At the end of the period, it's back to 0. Sketch that in. That's the sketch of our graph y equals -1/2, the sine of 1/2 theta. Has an amplitude of 1/2, period of 720, or 4 pi, and this negative sign again reflects the graph over the x-axis. Let's look at some generalizations of the cosine graph. At the beginning of its period, or 0 degrees, it starts at a maximum. 1/4 of the way through, it hits 0. Halfway through, it's its minimum. 3/4 of the way through, it's 0. And the end of the period, it's its maximum again. If that coefficient a is negative, then the maximums become minimums. The minimums become maximums as we reflect it across the x-axis. So let's graph one. Sketch of 4 times the cosine of 2 theta. 4 means we're going to go up to 4 as our highest point, maximum, down to -4 as our minimum. We take 360 divided by the absolute value of 2, which is 180, and that's the period. So we want to break that in fourths. Half of 180 is 90. Half of 90 is 45. 45 and 90 is 135. Cosine, we said, started at a maximum. Fourth of the way through was 0. Halfway through was a minimum. 3/4 of the way through was 0. And at the end of its period, hits a maximum again. And so as we sketch those points in, there's that basic U-shaped curve we talked about that the cosine has if we just look at it for its period. So again, for this particular example, the amplitude is 4. The period is 360 divided by the absolute value of 2, or 180. All right, let's look at one last one. Let's make this negative. So all the maximums will become minimums. All the minimums will become maximums. 360 divided by 1/3 is 360 times 3, or 1080. Half of that is 540. Half of 540 is 270. 270 and 540 is 810. Cosine starts out normally at a maximum, but since this is negative, it reflects across the x-axis and starts at a minimum. And fourth of the way through, it's 0. Half of the way through, instead of its minimum, it's a maximum because we're reflecting it due to this negative sign. And then 3/4 of the way through, it's 0. And normally at the end of the period, it would be maximum, but because we're reflecting it, it becomes the minimum. Sketch that curve in. There's our upside down U for the cosine for its period. And in this case, this has an amplitude of 3/4 and the period of 1080 degrees. And that's our look at sketching the graph of sine and cosine.